What is an angle? It is formed by rotating a given ray about its endpoint to some terminal position. So in this case, this is the initial side, and you can rotate this ray about its terminal side up to this. The common endpoint is called the vertex. There is also a positive angle and a negative angle. So we can call a positive angle wherein, starting from this initial side, you can move this ray in a counterclockwise direction up to this terminal side. While the negative angle, you will start from this initial side and you will move this ray in a clockwise direction along with this terminal side. An angle in standard position means, starting from initial side, which is on the positive x-axis, you can rotate this initial side along with the terminal side that lies in any of the quadrants. The terminal side can be on the first quadrant, on the second quadrant, third quadrant, or in the fourth quadrant. So we can say that the angle is in standard position. We can measure the angle in two ways. One is degree measure. When you say degree measure, 1 degree is a measure of an angle formed by rotating a ray. So suppose this is a ray. If you will rotate this ray 1 out of 360 of a complete revolution, then that is equivalent to 1 degree. So in symbol, 1 degree is equivalent to 1 out of 360 of a revolution, meaning on this one revolution or rotation, you will divide this into 360 equal parts. So 1 out of 360, that is equal to 1 degree. Let's have an example of an angle in degree measure. The first one is 360 degrees. So this angle is formed if the initial side rotates this ray along with this counterclockwise direction and initial side is equal to the terminal side. So this angle formed as one revolution or one rotation, or equivalent to 360 degrees. The second one is a right angle. This right angle is formed when this initial side moves along with counterclockwise direction up to this terminal side. So this form as 1/4 of the revolution or 1/4 of the rotation, and this is equivalent to 90 degrees. The next one is the straight angle. Straight angle, this is 1/2 of the revolution, and this is formed when this initial side or this ray formed on the counterclockwise direction up to the opposite of this initial side. So this is called a straight angle, and this measures 180 degrees. Another type of angle measurement is a radian measure. 1 radian is a measure of a central angle. When you say central angle, that is an angle whose vertex is at the center of the circle. So this central angle is formed by this arc of length r of a circle of radius equal to r. So the formula in finding for the arc length or for this angle theta or the central angle theta is equal to S over R, where S is the arc length. So this is the angle formed by this angle, S, divided by R, which is the radius of the circle. If the arc length, this arc length, or this one, is equal to the radius of the circle, so we can substitute S, which is equal to R, and R divided by R is equal to 1 radian. So this is how you will measure 1 radian. We can convert the angles from degrees to radians and from radians to degrees. So let us see the relationship between degrees, radians, and revolution. 1 revolution is equivalent to 360 degrees, and in radian, that is equal to 2 pi radians. Pi is equivalent to 3.14, so we can say 2 times 3.14 is equivalent to 6.28 radians. Half of the revolution or half of the rotation measures 180 degrees, or that is half of the 2 pi, which is equal to pi. So that's why 1/2 of the revolution is equal to 180 degrees, which is equal to pi radians. This pi radians in real number, you can convert this pi as 3.14. So we can say that this measures 3.14 radians or pi radians or 180 degrees. While 1/4 of the revolution is equivalent to 90 degrees, which is half of this 180 degrees. So this measures 90 degrees, or in pi radian, that is pi over 2. If you will convert pi into 3.14, then 3.14 divided by 2 is 1.57. So this angle measures 1/4 of the revolution, or 90 degrees, or pi over 2 radians, or 1.57 radians. So to convert radian to degree or vice versa, you can use this factor pi over 180 degrees radian if you want to convert from degree to radian. But if you want to convert an angle from radian to degree, you can use the factor 180 over pi degree. What are quadrantal angles? These are angles whose terminal side lies in the axis. So this is in the positive x-axis, negative x, positive y, and the negative y. These are the quadrantal angles in degrees. Starting from the positive x-axis, which is 0 degree, you will just add 90 degrees to get the quadrantal angle. So 0 plus 90 degrees, 90, then add another 90 degrees to get 180 degrees. Then add another 90 to get 270 on the negative y-axis. Then add another 90 to get 360. And then if you want to continue to get another quadrantal, just keep on adding 90 degrees. Then another quadrantal angle whose measures is in pi radian. So we have this positive x-axis, which is 0 radian. And then 1/4 of 2 pi radian, it's pi over 2. So you would just add pi over 2 because pi over 2 is equivalent to 90 degrees. Then adding pi over 2 to pi over 2, you will get pi in the negative x-axis. And then adding pi over 2 to pi, you will get 3 pi over 2 in the negative y-axis. And then adding pi over 2 again, you will get 2 pi. So keep on adding pi over 2 to get another quadrantal angle. And then lastly is the angle measured in radian, not in pi radian. So meaning you will just convert this pi into 3.14. So 3.14 divided by 2, which is equal to 3.57. So this pi is 3.14. This 3 pi over 2 is 4.71. And this 2 pi is 6.28. So let's just be aware on the values of the radian in the positive x. So this is 0. Next is, this is pi over 2. It's equivalent to 1.57 radian. Then this pi is equivalent to 3.14 radian. This 3 pi over 2 radian is equivalent to 4.71 radian. And then 2 pi is equivalent to 6.28. So if you want to get another quadrantal angle in radian, so you will add 1.57 to 6.28. So as you can see here, we can also have a negative quadrantal angles. So that means if the direction is clockwise direction, so this is 0, and then this one is negative 90 degrees, this is negative 180 or negative pi, and then this is negative 270 or negative 3 pi over 2, and then this is negative 2 pi. So these are examples of quadrantal angles. Let us be familiar with angle in quadrants and quadrantal angles. We can divide the coordinate plane into 4 quadrants. So if we intersect the x-axis and the y-axis intersecting at the origin, so we can have 4 quadrants. So this is the first quadrant wherein x and y are both positive. This is the second quadrant where x is negative and y is positive. And this is the third quadrant where both x and y are negative. And this is the fourth quadrant where x is a positive and y is a negative. So if we want to know where where is the location of the terminal side of each angle, so like for example in this example A, so the angle is in standard position as we can see because the initial side lies on the positive x-axis and the terminal side lies after 90 degrees. So we can say that this angle lies in quadrant 2. For letter B, the angle theta lies in fourth quadrant, and you can see that angle theta, this is in the clockwise direction, meaning this is a negative angle. So this is a negative angle theta. And then on letter C, it seems that the angle theta is not, the terminal side of the angle theta lies not in the quadrant, but in the axis. So we can say that this theta is a quadrantal angle, and this also an angle in standard position. Let us solve this example 1. Convert the following as indicated. Letter A, the given is 150 degrees, and we want to convert this to radian. So to do that, 150 degrees, we want this measure in radian, so therefore we have to multiply this with pi over 180 degrees. So as we have discussed in the previous slide, we can convert degree to radian if we will multiply this factor pi over 180 degrees. So if we will multiply this, so that will be equivalent to 5 pi over 6. You will simply simplify or get the lowest term of 150 over 180. So it will give you 5 pi over 6, and this will be in radian. For letter B, the given is a negative angle, which is negative 3 pi over 4, and this is in pi radian, and you want to convert this to degrees. So to do that, so with this 3 pi over 4, since we want to cancel this pi, so your multiplier would be pi in the denominator and the numerator is in degrees. So meaning you will multiply this bit with 180 degrees over pi. Then you can cancel the pi and multiply 180 degrees to negative 3 over 4 to get negative 135 degrees. For letter C, the given angle is 3 radians. Take note, this is without pi. It is 3 radians, meaning pi is already converted to real number. So to do that, since this is in radian, and as we said, to convert radian to degree, so the multiplier should be 180 over pi. Even there is no pi here, your multiplier would be 180 degrees over pi. So just multiply them. 3 times 180 is equal to 540 divided by pi. So that will be equivalent to 540 over pi in degrees. So this will now be in degrees. Okay. So you can convert this pi into real number 3.14, which is approximately equal to 171.89 degrees. And for letter D, this is 7 over 6 rotations, and we want to convert it to degree and radian. So to do that, so let's start with this 7 over 6 rotations, and let us see the relationship of rotations to degree. So we can multiply this with 360 degrees, which is equivalent to 1 rotation, and then we can cancel this unit of rotation and then multiply the 7 over 6 to 360. So we will get 420 degrees. Then if we want to convert this 7 over 6 rotations to radian, so 7 over 6 rotations, so let's see the relationship of one rotation to radian. So we know that one rotation is equivalent to 2 pi radian. So multiply this with 2 pi over 1 rotation. Then you can cancel the rotation and then multiply 2 pi to 7 over 6. Then your answer would be 7 pi over 3 radian. For this example 2, we will determine whether the terminal side of the following angle lies in the first, second, third, fourth quadrant, or they are quadrantal angle. So for the first angle, it's 153 degrees. 153 degrees is more than 90 degrees, but less than 180 degrees. So we can say that the terminal side lies on the second quadrant. So that is a second quadrant angle. The second angle is negative 180 degrees. Since this is negative, so we can say that the direction of this angle is a clockwise direction, starting from this positive x-axis. This is negative 90 degrees. Then add another 90. This is negative 180 degrees. So we can say that this is a quadrantal angle. Then for number 3, it's 1048 degrees. As we know, one revolution or one rotation is equivalent to 360. So we can say that 2 revolutions is equivalent to 720 degrees. And 3 revolution is equivalent to 1080 degrees. So again, 360, 720, and another revolution is 1080. Our angle is 1048. 1080 is 3 revolution, meaning it will lie, the terminal side will lie on the positive x-axis again. So 1048 is somewhere here in quadrant 4. So we can say that 1048 degrees is a fourth quadrant angle. Then the next angle is 15 degrees. 15 degrees is more than 0 degree but less than 90 degrees. So we can say that that is a first quadrant angle. Then the next angle is 5 pi over 4. So as you can see, this is in pi radian. And you do not need to convert this to degrees to be able to know the terminal side of this pi radian. So what you can do is, you know that this is pi. So we are looking for 5 pi over 4. So when this is pi, and when you divide this into 4 equal parts, so you can say that there are 4 pi over 4 from this part up to this. Since we need 5 pi over 4, so from this side, I will just add another pi over 4 to get 5 pi over 4. So again, so we know that this is pi, and we want to know the terminal side of 5 pi over 4. So meaning, on this pi over 4, what I will do in pi, I will divide this into 4 equal parts. So that means, from this up to this, there are 4 pi over 4, right? Then, since we want 5 pi over 4, from this 4 pi over 4, I will add another pi over 4 to get 5 pi over 4. So 5 pi over 4 is a third quadrant angle. The next is 4 pi. 4 pi is a pi radian, and if we will measure it, one revolution is 2 pi, and then if we move to another revolution after 2 pi, we will get 4 pi. So we can say that 4 pi, the terminal side of 4 pi, will lie on this positive x-axis, and that is a quadrantal angle. So for more exercises, you can do the following. You can convert each angle in degrees to radians, and you can express each answer as a multiple of pi. And then for the second one, you can convert each angle in radians to degrees. So that's for section 7.1. So this slide will continue to section 7.2.